Welcome to chemistry classes. In this video we are going to discuss about covalent bond and different example for covalent bond. Covalent bond. Okay. Look here. These are group 17 elements. Fluorine, chlorine, bromine, iodine. These are group 17 elements. These are halogens. We know halogens exist in the form of F2, Cl2, Br2, I2. They exist in the form of diatomic. They are diatomic molecule. We can explain why halogens are in diatomic form based on covalent bond. We can explain this based on covalent bond. Okay. Also you can see some other example, hydrogen, H2, oxygen, O2, nitrogen, N2. Also this type of molecules are diatomic form. Why they are in diatomic? We can explain based on covalent bond. See here, fluorine, atomic number of fluorine 9. First shell 2 electrons, second shell 7 electrons. And this is the electronic structure of fluorine. First shell 2 electron, second shell 7 electron. We know second shell there must be 8 electron, here only 7 electron. Fluorine need one more electron to complete its outer shell. So one possibility to attain its stability, outer shell 7 electron mean this fluorine atom not stable. It need one more electron to attain its stability. So here one possibility to attain stability, one possibility to get one more electron, ionic bond. Fluorine react with metals form ionic bond. We discussed already ionic bond. Here fluorine react with the sodium. Fluorine react with the sodium. Look here. Here Fluorine react with the sodium form sodium fluoride. Okay, here sodium reacted with the fluorine form sodium fluoride. In sodium fluoride there will be ionic bond. During this chemical reaction, one electron will transfer from sodium to fluorine. Fluorine receive one electron and form sodium fluoride. Then fluorine gets stability. This type of compounds are ionic compound, and this type of possibility already we discussed. Okay, here we have to study second possibility to get stability for non-metal. How fluorine gets stability? Second method. This method is covalent bond. Okay, so one possibility to get stability for fluorine reacted with metal form ionic bond. Electron will transfer from metal to fluorine. Fluorine gets 8 electron its outer shell and fluorine gets stability. Look here, another possibility here, two fluorine atoms share one pair of electron. Two fluorine atoms share one pair of electron. Look here, this is one fluorine, this is another fluorine. Both fluorine its outer shell. We know fluorine atomic number 9, first shell 2 electrons, second shell 7. I used only this 7 electrons here. Here fluorine its outer shell 7 electron, 2, 4, 6, 7. Okay, and this electrons are called valence electron. Valence electrons. We use only valence electrons to draw covalent bond. So here one method to get stability for fluorine reacted with metal form ionic bond. Fluorine reacted with metal form metal fluoride. Metal transfer one electron to fluorine and fluorine getting 8 electron its outer shell and fluorine getting stability. We have to discuss here second possibility. Two fluorine atoms share one pair of electron. See here, we know fluorine atomic number 9, first shell 2 electron, second shell 7 electron. second shell 7 electron. Okay, this is outer shell. In outer shell only 7 electron. This outer shell electrons are called valence electron. Remember this, outer shell electrons are called valence electron. Okay, so here two fluorine atom, I used only valence electrons over here. Valence electrons are 7. So here one fluorine atom with 7 electron, another fluorine atom with 7 electron. They react together and they share one pair of electron. See here, this is one fluorine and this is another fluorine. Here both fluorine atoms sharing one pair of electron. One pair of electron means 2 electron. They share 2 electron. Okay. Here you can see here this circle represent electrons of this fluorine and this cross represent electrons of this fluorine. Okay, and they share one pair of electron. One pair of electron. So between two fluorine atom they share one pair of electron. One pair of electron means we used to represent like this. Two fluorine atoms share one pair of electron. One pair of electron means single bond. In some case you can see two atoms share two pair of electron. I will give you more example here. Some case two atoms share two pair of electron. If there are two pair, we will use to represent two line. It is double bond. Two pair of electron sharing mean double bond. Sometime you can see two atoms share three pair of electron. Three pair of electron sharing we will use to represent like this, and it is triple bond. Here it is triple bond, three pair of electron sharing. Here two atoms sharing two pair of electron, double bond. Here fluorine atom share one pair of electron. One pair of electron mean two electron sharing. Two pair of electrons mean four electrons sharing. Three pair of electrons mean six electrons sharing. Okay, so here we discussed here fluorine, it is unstable because its outer shell only 7 electron. One possibility to get stability, fluorine react with metal form ionic bond. Second possibility we discussed here, two fluorine atoms react together or two fluorine atoms share one pair of electron. Because both fluorine atom need one more electron to complete its outer shell. So two fluorine atoms share one pair of electron and they attain stability. Okay, if they sharing one pair of electron, we will represent fluorine single bond fluorine. Here in oxygen case, I will give you example for this. Okay, you just understand, if two atoms sharing two pair of electron, so it will be double bond, two line. If they sharing three pair of electron, triple bond, three lines, triple bond. Clear? Okay, so here we discuss two fluorine atoms share one pair of electron. We know in the middle of each fluorine atom there is positively charged electron. This positively charged electron attract negatively charged electron. Okay, in the middle of atom there is positively charged nucleus, and this positively charged nucleus attract negatively charged electron, and each fluorine atom attract each other, and this force of attraction is called covalent bond. Okay. Here two fluorine atoms share one pair of electron. Each fluorine atom, in the middle of each fluorine atom there is positively charged nucleus. This positively charged nucleus attract negatively charged shared electron, and there will be a force of attraction between each fluorine atom and they will attract each other. This type of force of attraction called covalent bond. Okay, in case of ionic bond we discuss oppositely charged metal and non-metal attract each other. Electrostatic force of attraction between oppositely charged metal and non-metal called ionic bond. Okay, here force of attraction between nucleus and negatively charged electron. Okay, this force of attraction helps to join two fluorine atom, and this force of attraction is called covalent bond. Okay, now here two fluorine atoms sharing to attain their stability, and they became F2. They became diatomic molecule. Okay, now see here, let us see another example for covalent bond. Here oxygen, O2, oxygen. Okay, we know oxygen, atomic number of oxygen 8. Atomic number of oxygen 8. First shell 2 electron, second shell 6 electron. I told you before, we will use only valence electrons to represent covalent bond. O2 means 2 oxygen atom. Each oxygen atom need 2 more electron. Here second shell only 6 electron. Each oxygen atom need 2 more electron to attain their stability. To complete outer shell, it need 2 more electron. So each oxygen atom share 2 pair of electron. Here 2 oxygen atom. Each oxygen atom share 2 pair of electron. Here 2, here 2. Why 2 pair? Because here oxygen need 2 more electron. So each oxygen atom share 2 pair of electron. Okay, so I used here X, so we have to draw here X. Okay, oxygen outer shell 6 electron, 2, 4, 6, including this 2X, here 6 electron. Next, this oxygen, I used here O to represent electrons of this oxygen. Here 2, 4, 6, including this 8. Okay, now each oxygen atom getting 8 electron. See here 2, 4, 6, 8. So this oxygen getting 8 electron. Similarly, this oxygen 2, 4. Look here, 2, 4, 6, 8. Both oxygen atom getting 8 electron. Now each oxygen atom share 2 pair of electron. I told you before, 2 pair of electron mean 4 electron. So each oxygen atom sharing 2 pair of electron. So between 2 oxygen atom there is double bond. Okay, it is double bond. 2 pair of electron sharing. Clear? Next one we can see here another example. H2, hydrogen. Atomic number of hydrogen is 1. Atomic number of hydrogen 1. First shell 1 electron. We know first shell there must be 2 electron. Here only 1 electron. So here each hydrogen atom. Here hydrogen outer shell 1 electron. It need 1 more electron. Okay, 1 more electron. So we have to draw here 2 hydrogen atom. Okay. And it need 1 more electron, so it share 1 pair of electron. Before here oxygen it need 2 more electron, so they share 2 pair of electron. Okay, here 1 more electron, it need 1 more electron, so it share 1 pair of electron. 1 pair of electron. Okay, so here hydrogen outer shell only 1 electron, we did that electron. So no more electron over here. No more electron. Only 1 electron in hydrogen atom we did. Okay. So between hydrogen atom they share 1 pair of electron. So hydrogen hydrogen single bond. So this is hydrogen hydrogen single bond. Clear? See here another example. Cl2 chlorine. Cl2 chlorine. Chlorine atomic number. Chlorine atomic number 17. Okay, what's the atomic number of chlorine? 17. So here first shell 2 electron, second shell 8 electron, third shell 7 electron. 2, 8, 7. 287, 7. So it need one more electron. It must be 288. Here 7 electron. So here chlorine need one more electron. One more electron. So it share how many pair of electron? It share one pair of electron. Okay, so here two chlorine atom share one pair of electron because it need one more electron. Chlorine atom sharing one pair of electron. Clear? Here not completed. Here we know chlorine outer shell 7 electron. Chlorine outer shell 7 electron. We did 1 electron only. This is one chlorine. We did 1 electron. How many electron left? Total 7 electrons in outer shell. 7 electron. We did 1. How many left? 6 electron left. So we had to do here 2, 4, 6. Now this chlorine 7 electron and including this 8 electron getting stability. What about this chlorine? Only 1 we did, remaining 7. Remaining 6. Okay. So here 2, 4, 6, 7. Including this 8. So two chlorine atom share one pair of electron. So chlorine single bond. So you have to do electronic structure and see here how many more electron needed. So accordingly here it need one more electron, one pair of electron sharing. In case of oxygen it need two more electron, so it share two pair of electrons. It share two pair of electron. Clear? Okay, let us see how water molecule make covalent bond. Water molecule H2O. Okay, H2O, 2 hydrogen and 1 oxygen, that is water molecule. Okay, so water molecule hydrogen and oxygen. Hydrogen atomic number 1, only 1 electron its outer shell. Oxygen we did before, atomic number 8, 2,6. Okay, outer shell 6 electron. Here oxygen need 2 more electron, hydrogen need 1 more electron. So H2O mean 2 hydrogen and 1 oxygen. 1 oxygen, 2 hydrogen. Okay, this is oxygen, hydrogen. Here hydrogen need 1 more electron. So hydrogen and oxygen share 1 pair of electron. I told you before, here it need 1 more electron mean it share 1 pair of electron. Here I use X to represent electrons of hydrogen and O to represent electrons of oxygen. Okay, you can use anyway. I used here hydrogen X and oxygen O. So here hydrogen and oxygen share 1 pair of electron. Similarly here this hydrogen and oxygen also share 1 pair of electron. Now hydrogen getting 2 electron its outer shell. What about oxygen? Oxygen outer shell 6 electron. I put here 2 electrons for oxygen. Out of 6 we did here 2 electron. How many left? 4 electrons left. This 4 electron we can do over here. Okay, so oxygen, now see here oxygen including all electrons 2, 4, 6, 8. Oxygen getting 8 electron its outer shell, hydrogen getting 2 electron its first shell. Now water molecule getting stability. Okay, so this is water molecule. See here another example, HCl. HCl means hydrogen chloride, HCl. Again here hydrogen atomic number 1, 1 electron, chlorine atomic number 17. Chlorine atomic number 17, 287. Chlorine atomic number 17, 287. Okay, so here both hydrogen and chlorine need 1 more electron. Hydrogen outer shell 1 electron. It need 1 more to complete its first shell. What about chlorine? 287. It must be 288. So chlorine need one more electron. So chlorine need one more electron. Hydrogen and chlorine both need one more electron. Okay. So here hydrogen and this is chlorine. Chlorine bigger atom. Okay. Atomic size bigger. So this is chlorine and this is hydrogen. Hydrogen first shell how many electron? Only one electron hydrogen. Okay, and here chlorine 1. Both hydrogen and chlorine need one more electron, so they share one pair of electron. Okay, here chlorine 7 electrons over here, we did only 1. How many left? 6 electrons left. Chlorine 7 electrons its outer shell. Okay, we did here 1, so left 6 electron. Now chlorine getting 8 electron. Look here, 2, 4, 6, 8. Including these 2 electron, chlorine getting 8 electron its outer shell. Now hydrogen and chlorine share one pair of electron. Hydrogen and chlorine share one pair of electron, HCl. See here another example, NH3. NH3 mean ammonia, NH3. Okay, so here NH3 mean here nitrogen. Before doing NH3, see here, let us do first N2. After N2 we can do NH3. N2 mean nitrogen molecule. Nitrogen atomic number 7, 2,5. 2,5. Okay, so here 5 electrons. So nitrogen need how many more electron? Nitrogen need 3 more electron. Nitrogen need 3 more electron because it must be 2, 8. Here 2, 5 only. So it need 3 more electron. So 2 nitrogen atoms share 3 pair of electrons. It need 3 more electrons. So they share 3 pair of electrons. Okay. Now see here outer shell 5 electron. We did 3 only. How many left? 2 more. Okay. So here nitrogen outer shell 5. 1, 2, 3, 4, 5. Including this, it is 8 nitrogen. This nitrogen getting 8 electron its outer shell. Look here, 6 plus 2, 8. Similarly about this nitrogen, similarly here this nitrogen we did 3 electron. How many electron left? 2 electron left. Okay, now here also 1, 2, 3, 4, 5, 6, 7, 8. Each nitrogen atom share 3 pair of electrons. So it will be nitrogen triple bond. Now we can do NH3. Similarly here nitrogen 2, 5. Okay, and hydrogen outer shell 1 electron. So here nitrogen need 3 more electron. Hydrogen need 1 more electron. So NH3 mean 1 nitrogen and 3 hydrogen. 1 nitrogen and 3 hydrogen. This is nitrogen and these are 3 different hydrogen. Hydrogen need 1 more electron. Hydrogen need 1 more electron. Okay, so we can do here hydrogen 1 more electron. So nitrogen and hydrogen share 1 pair of electron. In each case nitrogen and hydrogen share 1 pair of electron. Okay, now see here hydrogen getting 2 electron in first shell. Hydrogen getting 2 electron its first shell. Okay, what about nitrogen? Same here, I told you before, nitrogen outer shell 5 electron. We did here 1, 2, 3. We did 3. How many left? 2 left. This 2 electron we can do over here. So nitrogen, how many electron now? In case of nitrogen, how many electron? Here nitrogen getting 2, 4, 6, 8. Nitrogen getting 8 electron, its valence shell. Also hydrogen getting 2 electron, its first shell, and NH3 getting, NH3 became stable now. Okay, so this is NH3, HCl and H2O. Clear? Okay, next one, we have different molecules. Look here, first one, CH3OH. We can see here how CH3OH means methanol. We will study this type of molecules in organic chemistry. So let us see here CH3OH, how CH3OH make covalent bond. Okay, so see here CH3OH mean one carbon. CH3 mean one carbon and 3 hydrogen. This is carbon, hydrogen, hydrogen, hydrogen. This is CH3. Okay, then oxygen, CH3OH. This is oxygen and this is hydrogen. This is CH3OH. Clear? Now we can put the electron. Carbon. What's the atomic number of carbon? Carbon 6. Atomic number of carbon 6. 2, 4. Okay. And hydrogen atomic number 1. Okay. Oxygen atomic number 8. So 2, 6. Carbon 2, 4. Hydrogen 1. Oxygen 2, 6. Okay. Here I am using here X to represent electrons of carbon. X to represent electrons of carbon. Okay. Black dot to represent electrons of oxygen. O to represent electrons of hydrogen. We can use this type of representation based on question. In the question it will mention use X to represent electrons of particular element. Based on this we can use it. So I used here X to represent electrons of carbon, O to represent electrons of hydrogen, black dot to represent electrons of oxygen. Clear? Now see here carbon 4 electrons. We will use only valence electrons to represent covalent bond. We discussed already. We will use only valence electrons. So carbon 4 electron. 1, 2, 3, 4. Hydrogen only 1. Carbon we have to use X. Okay. Carbon X. Okay, carbon 1, 2, 3 and here also one more X. Okay, 4 electrons of carbon we did. Now what about hydrogen? Hydrogen we have to use this type of circle. Okay. Hydrogen here also 1. What about oxygen? Oxygen black dot here. Hydrogen only 1 electron its outer shell. We did 1 electron. Carbon valence electrons 4. We did 1, 2, 3, 4 electrons we did. What about oxygen? Oxygen outer shell 6. We did 1, 2. How many left? 4 electrons left. This 4 electrons you can do over here. This is the covalent bond for CH3OH. Clear? So here I did first CH3, carbon with 3 different hydrogen, then oxygen, then hydrogen. Then accordingly use X to represent electrons of carbon. I completed here electrons of carbon. Then I put O to represent electrons of hydrogen. Then I completed here electrons of oxygen. This is CH3OH. Okay. Here, look here, carbon with the carbon share one pair of electron with hydrogen. Carbon share one pair of electron with hydrogen, CH3. Also here carbon share one pair of electrons with oxygen. Also here oxygen share one pair of electron with hydrogen. So this is CH3OH. This is CH3OH. This single line represents single bond, one pair of electron sharing. Clear? After CH3OH, let us see here CH4. How CH4 molecules formed. CH4 mean one carbon and four hydrogen. CH4 mean one carbon, four different hydrogen. This is CH4. Okay, we know electronic structure of carbon 2 4. So carbon need 4 more electron. It need 4 more electron. What about hydrogen? Hydrogen 1 electron, it need 1 more electron. So hydrogen need only 1. Okay, so we have to use here hydrogen 1 electron. Here only 1, so we have to use X over here. Clear? Now what about carbon? Carbon 1, 2, 3, 4, 4 electrons, its valence shell. We did all 4. Okay, now total electrons for carbon 2, 4, 6, 8. Carbon getting 8 electrons, its valence shell. Carbon became stable. And hydrogen getting 2 electron, its first shell. Hydrogen also became stable. Now this is CH4. CH4 mean methane. CH4 mean methane. CH4, it is gaseous state, it is methane. Okay. So this is CH4. Similarly, we can do here CCl4. CCl4 mean carbon tetrachloride. Tetra mean 4. Carbon tetrachloride. That is CCl4. Let us see here how carbon tetrachloride formed. Carbon tetrachloride means same. Here carbon and 4 different chlorine. This is carbon and 4 chlorine atom. We know carbon 2, 4 electrons, its valence shell. Okay, so first let us complete carbon 4 electrons. Okay, now we know chlorine atomic number 17. Electronic configuration. What will be the electronic structure? Electronic structure will be 2, 8, 7. Here 7 electron. So it need 1 more electron. It need 1 more electron. Clear? So here chlorine need 1 more electron. Each chlorine atom need 1 more electron. Chlorine outer shell 7. We did only 1. How many left? 6 left. 2, 4, 6. Okay, now here 2, 4, 6, 7. Similarly, all this we have to make it 7. Okay, now see here chlorine atom 2, 4, 6, 7, including this 8, including X, chlorine getting 8 electron. Now each chlorine atom became 8 electron its outer shell. What about carbon? Carbon, look here, 2, 4, 6, 8. Each here carbon atom getting 8 electron, okay, including all this electron. So this is CCl4. CCl4 mean carbon tetrachloride. Okay, let us see here how carbon dioxide make covalent bond. Carbon dioxide. Carbon dioxide mean 1 carbon and 2 oxygen. 1 carbon, 2 oxygen. So carbon in the middle, 2 oxygen atom in each side. Okay, carbon and oxygen. Look here, carbon, oxygen, carbon atomic number 6, 2, 4, oxygen atomic number 8, 2, 6. So here, carbon need how many more electron? Valence shell 4. It need 4 more. It must be 2, 8. It need 4 more electron. Oxygen need 2 more electron. Oxygen need 2 more electron. Okay, so look here, this oxygen atom need 2 more electron. So we have to do here 2 2 because it need 2 more. Similarly here, this oxygen, it need 2 more electrons. So we have to do here 2 2. Clear? Carbon valence electrons 4. We did 1, 2, 3, 4. Valence electrons of carbon we did. What about oxygen? Oxygen valence shell 6 electron. We did 2 only. How many left? 4 left. Valence electron 6. Including this 2, 1, 2, 3, 4, 5, 6. Here also we have to make it 6. Okay. Now here oxygen. Oxygen getting 8 electron. Here total electrons now 2, 4, 6, 8. Also here you can see 2, 4, 6, 8. Oxygen getting stable electronic structure. What about carbon? Carbon 2, 4, 6, 8. Here 4 electrons, here 4 electrons. Now this is carbon dioxide. Here 1 carbon and 2 oxygen, they share 2 pair of electrons. So this is the structure of carbon dioxide. Clear? After carbon dioxide, let us see how C2H4. Before C2H4, let us do here CH3 single bond CH3 or CH3 single bond CH3. CH3 single bond CH3 mean here 1 carbon with 3 hydrogen. I told you before CH3OH. CH3OH mean 1 carbon and 3 hydrogen. That is CH3. Okay. CH3. This is CH3. I did this part. Again there is another CH3. Here 1 more carbon with 3 hydrogen. Here each carbon atom share 1 pair of electron. That is CH3 single bond. Single bond means this carbon and this carbon share 1 pair of electron. Clear? So here CH3, CH3. Next here carbon, we know 2, 4, hydrogen only 1. So carbon need 4 more electrons. Okay. Hydrogen, we can use here X to represent electrons of hydrogen, O to represent electrons of carbon. So here hydrogen, X, here also hydrogen, X. What about carbon? Carbon O. Here hydrogen need 1 more electron. That's why we did 1 pair of electron. Look here, carbon valence electrons 4. Carbon valence electron 4. How many electron we did? 1, 2, 3. How many left? 1 more left, 4. Because here carbon single bond. These 2 carbons share 1 pair of electron. Okay. This carbon also same way, carbon and hydrogen 1 pair of electron. We did here 1, so 1 more electron over here. Now this is CH3 single bond CH3. CH3 single bond CH3 mean 1 carbon single bond with 3 hydrogen, that is CH3. Then this carbon and this carbon single bond, and this carbon again making 3 different single bond with hydrogen. So this is CH3 single bond CH3. Okay, next one we have to understand here shapes of the molecules. Shapes of the molecules. Different molecules, they have different shape. Okay, so see here we discussed before NH3. NH3 mean nitrogen and 3 hydrogen share one pair of electrons and they make covalent bond. In NH3 there is two different type of electron pair. Here nitrogen and hydrogen, they share one pair of electron. This pair of electrons, they involve chemical bonding. Such type of electron pairs are called bond pair electrons. This type of electron pairs are bond pair electron. And here this electron pair do not involve chemical bonding. This type of electron pairs are called lone pair electrons. Here this electron pair, these two electrons do not involve any type of chemical bonding. They are lone pair electron. This is bond pair electron. We know electrons, they have negative charge. So this pair of electrons, they repel each other. Bond pair and lone pair electron repel each other. Okay, and this is the order of repulsion. Lone pair mean electron pair, they are free. They do not involve any type of chemical bonding. They are staying free and their repulsion is greater. Okay, and see here these electron pairs are in bonding and they have less repulsion, and here this electron pair, they are free. They did not made any type of bonding and they have higher repulsion. So this is the order of repulsion. Lone pair electrons. Imagine two lone pair electron, their repulsion will be greater. Okay, here see here in water molecule, this is water molecule, you know, oxygen and 2 hydrogen, they make covalent bond. This is water molecule. In water molecule there is 2 lone pair electron. These are the 2 lone pair electron here. Water molecule, there is 2 lone pair electron, and these lone pair electrons, they have greater repulsion compared to bond pair electrons. Clear? So here this is the order of repulsion. Lone pair repulsion is greater than lone pair bond pair repulsion. Imagine this is bond pair electron and this is lone pair electron. So repulsion between bond pair and lone pair repulsion is less compared to this lone pair and lone pair repulsion. Also this is greater than this one. Here this is bond pair. This bond pair repulsion will be very less compared to lone pair bond pair repulsion. It is less than compared to lone pair repulsion. So electron pair, they do not involve any type of chemical bonding. They are lone pair electron and they have greater repulsion compared to bond pair electrons. Okay, so here this electron pairs stay maximum apart to get maximum stability and least energy. The molecules need stable. That's why molecule making ionic bond, covalent bond to get stability. If there is electron pair, this electron pair repel each other and this electron pairs stay maximum distant, maximum apart to get maximum stability. Okay, and this why here molecules getting definite geometry and bond angle. Here look here this is NH3 pyramidal shape. This shape of NH3, this shape is called pyramidal shape, and bond angle here, this bond angle is 107 degree. Okay, and here this is water molecule, and this is bend shape. shape of name, here bend shape, and here bond angle is 104.5 degree, and this is carbon dioxide, and this is linear shape, and here bond angle is 180 degree. So here different molecules getting different geometry and different bond angle, definite geometry and definite bond angle because of the repulsion between electron pairs. These electron pairs repel each other and stay maximum apart and getting maximum stability. Okay, and this is the order of repulsion. Lone pair repulsion is higher than lone pair bond pair repulsion. It is higher than bond pair repulsion. Clear? Okay, next one we have to discuss here different properties of ionic and covalent compounds. Different properties of ionic compounds and covalent compounds. Okay, so see here, ionic compounds, the physical state of ionic and covalent compound. Ionic compounds generally solid state, but covalent compounds they exist liquid state, solid state and gaseous state. Some compounds solid state, some of them liquid state and gaseous state. But most of the ionic compounds are in solid state. Next one, solubility. Ionic compound soluble in water, sodium chloride, potassium chloride, this type of ionic compounds generally soluble in water, but covalent compounds generally insoluble in water and they soluble in organic solvent. Covalent compounds generally insoluble in water but soluble in organic solvents such as carbon disulfide, benzene, etc. Okay. And here electrical conductivity. Ionic compounds, the aqueous solution of ionic compounds. Aqueous solution of ionic compounds, molten form of ionic compounds pass electricity. Aqueous solution. Okay, ionic compounds dissolve in the water and it will pass electricity. That is, aqueous solution of ionic compounds dissolve electricity. Also molten compound. Ionic compounds heat very strongly and it will melt and it will pass electricity. Okay, so here aqueous solution of ionic compounds and molten form of ionic compounds pass electricity. But generally covalent compounds are poor conductor of electricity. Okay, covalent compounds are poor conductor of electricity. And here melting point of ionic compounds are very high. Melting point of ionic compounds are very high. Similarly, melting point of covalent compounds are low. They have low melting and boiling point, but ionic compounds they have high melting and boiling point. Okay, so these are the things we have to discuss in this video. You can check past paper question related to this. You can check playlist and you can see different past paper question related to this topic. Okay, and you can review this video again, and thank you for watching this channel.